Welcome to FMSP Online Revision. This session is for OCR D1 and the topic that we're going to be looking at is the simplex algorithm. So we'll start by having a look at the specifications for linear programming in general, and I will mention that there is another session which covers the graphical linear programming bit in A and C. So in the graphical linear programming video, there is a bit on formulating a real-world problem and carrying out the graphical solution. What we're going to be doing in this session is B and D, in other words, the simplex. So candidates should be able to set up a linear programming formulation in the form maximize or minimize objective, subject to inequality constraints and trivial constraints of the form variable greater than or equal to naught, and use slack variables to convert inequality constraints into equations together with trivial constraints. And they then must be able to use the simplex method for maximizing an objective function, interpret the values of the variables and the objective function at any stage in the simplex method. So what we're going to do now is we're going to look at a question which will hopefully cover as many of those points as possible. So we'll start by looking at this question, which is a linear programming problem to minimize, and I'll mention that of course the simplex is purely a maximizing algorithm. So what we have to do first of all in part 1 is we've got to convert it into a maximizing problem, and we're told to do that by replacing A by 20 minus x, B by 20 minus y, C by 8 minus z, and by doing that the first thing we have to do is show that we can write it in that form. We then in part 2 have got to represent the problem as an initial simplex tableau, perform one iteration of the simplex algorithm, explain how the choice of pivot was made and show how each row was obtained, and then write down the values of x, y and z at this stage and hence the corresponding values of A, B and C. And then in part 3, if additionally the variables A, B and C are non-negative, what additional constraints are there on the values of x, y and z? So the first part is to try and set up the maximizing problem. It's worth 3 marks. Notice that the performing of the simplex is 11 marks, and then this last little bit 2 marks. So let's see if we can start then on part 1. So by replacing A by 20 minus x, B by 10 minus y, etc. So we'll start first of all with the objective function. So let's see if we can convert that. So we have the function 2a minus 3b plus c plus 18. So everywhere we have an a, we have 20 minus x, so that's going to be 40 minus 2x. B is 10 minus y, so just be careful with your signs, so that's minus 30 plus 3y, and C is 8 minus z, and then we have the plus 18. So if we simplify all of that, we'll have minus 2x plus 3y minus z, and then we have 36 as our constant. Now we have got to minimize that expression, and of course basically therefore we have got to minimize minus 2x plus 3y minus z. This really will have no effect. So effectively we're minimizing this, because this 36 is constant. We can't do anything with that. And that means that that will be equivalent to maximizing 2x minus 3y plus z. So hopefully that is okay. So we've got the first bit. I'm then going to take the first of the constraints, which is a plus b minus c is greater than or equal to 14, and again substitute in. So I would get 20 minus x plus 10 minus y minus c will be minus 8 plus z is greater than or equal to 14. But if we simplify that, we'll get 30 minus 8, so it's 22 minus x minus y plus z is greater than or equal to 14. So that is minus x minus y plus z is greater than or equal to minus 8, or x plus y minus z is less than or equal to 8. So we now have the first of our constraints. We would go ahead then and do the same thing for each of the other constraints, so for these next two. So I have done that here and worked out the second constraint in terms of x and z, and the third one. And the last thing we have to do is to consider the trivial constraints now. So we are told that a is less than or equal to 20, but that implies that 20 minus x is less than or equal to 20. So that tells us that x has got to be greater than or equal to 0. We're also told that b is less than or equal to 10, and we know that b is equal to 10 minus y, so that will give us y is greater than or equal to 0. And c is less than or equal to 8, but again c is equal to 8 minus z, so that will tell us that z is greater than or equal to 0. Now, as I say, there were only 3 marks for this part. So you got 1 mark for converting the objective function, 1 mark for converting these constraints, and 1 mark for the trivial constraints. So we'll now move on to setting up the simplex. So let's just check on how we're going to do that. So the first thing we've got to do for the simplex, if I call the objective function p, then the first thing that we have to do is to rewrite this in the form p minus 2x plus 3y minus z equals 0. So that's what the simplex algorithm tells us that we've got to do. We've got to rearrange the objective function, put it equal to 0. We then have got to introduce slack variables. So I'm going to use S, T and U. You may do something different, but that's what I will do. So what we're going to do is we're going to take each of these inequalities and we're going to write them as an equation. So x plus y minus z less than or equal to 8, well, there will be some value of s which makes it equal to 8. And similarly, 2x minus 3z will introduce the slack variable t there, so that will be equal to 66. And 4x minus 5y, no z's, and we'll introduce a slack variable u to make that equal to 40. So that is the first thing that we need to be able to do. And having got that, we then need to put that information into our simplex tableau. So I've just copied that information here. Hopefully you can see that. So the first row of our table is going to be 1 lot of p minus 2x plus 3y minus z with no s's, no t's, no u's, and we start off at the origin where p is equal to 0. And then we go through each of these constraints and we put them into the table. So the first one, no p, 1x plus 1y minus z plus 1s, no t's are used, is equal to 8, and so on. So we set up our table in that form, and we then, I think it's best if we then number the table, or the rows in the table. So this is going to be number 1, 2, 3, and 4. So we have 4 rows to deal with, and what the Simplex algorithm tells us to do now is to choose a pivot. And the pivot we choose from a pivot column, and the pivot column will come from a variable where we have a negative value in the objective row. So in this particular case we have a choice of x or z. Now in the particular case of z, it wouldn't work because we are not allowed to have negative pivots and we can't have a 0 pivot. So z cannot be our pivot column, so it must be the x column. So the x column will be our pivot column. Now we have to find which of these numbers, 1, 2 or 4, are going to be our pivot. And the way we do that is to do a ratio test. So the ratio test takes the right hand side here, which is 8, and you divide it by the corresponding entry in the pivot column. So that would be 8 divided by 1, which is 8. And then you do the same thing here, so it would be 66 divided by 2, which is 33, and 40 divided by 4, which is 10, and the Simplex algorithm tells us that we have got to take the smallest of these. So this is referred to as the ratio test, and the smallest of these is when the pivot is 1. So we now have a pivot of 1. The Simplex algorithm tells you that you must make your pivot equal to 1. So if, for example, our pivot was 2 or 3, then we would have to divide this whole row, the pivot row, by 2 or 3. But on the basis that our pivot is 1, then we can just write down our pivot row just unchanged. And that pivot row, if I call this one row 5, our pivot row now is row 6, and that is unchanged. What we then have to do is we have now got to augment our table to find rows 5, 7 and 8. And the Simplex algorithm says that to do this we have got to make the entry above or below the pivot. These entries have got to become 0. So if this entry has got to become 0, then we are going to have to add 2 lots of 1 onto this minus 2. In other words, 2 lots of our pivot row. So our 5th row is going to be the first row plus 2 lots of the pivot row. And if we do that, so it's going to be row 1, 1 plus 2 lots of nothing, minus 2 plus 2 lots of 1, 3 plus 2 lots of 1, and so on. So hopefully we should be able to go through and complete that row. And we'll then do the same thing for row 7 and row 8. So we want to make this a 0. So we'll have to say 2 minus 2 lots of the pivot row. So it'll be the 3rd row minus 2 lots of the pivot row. So that is 0 minus 2 lots of nothing, 2 minus 2 lots of 1, and so on. And again we can just complete hopefully these entries as carefully as possible so you're not making any mistakes. And in this case, when we've just got whole number values, it's not so bad. Sometimes you've got fractions and you do have to be very careful. And then we want to make this entry a 0, so it's going to be 4 minus 4 lots of the pivot row. So it's going to be the same as the fourth row minus 4 lots of the pivot row. And again, if we do that, we'll end up with 0, 0, minus 9, 4, minus 4, 0, 1, 8. And now we have completed the first iteration. Notice that we actually still have a negative value in our objective row, so we haven't got the optimal solution. And sometimes you will be asked to perform a second iteration at this stage. But in our particular question, we were just asked to perform one iteration to explain the choice of the pivot and how it was made. So we've got the pivot column and we've shown the ratio test, so that should be okay. And then we've shown how each row was obtained by writing down these rules. And the last thing we need to do is to write down the values of x, y and z. Well, p is going to be equal to 16. Weren't actually asked for that, but it is. X will be equal to 8. So we have 1p equal to 16, 1x is equal to 8. Again, we're not actually specifically asked for it, but 1t would be 50 and 1u is 8. But y is equal to 0 and z is equal to 0. And then it says, hence write down the corresponding values of a, b and c. So we're using the results that we've got up there at the top, that a is equal to 20 minus x, so that means that a will be equal to 12. B is 10 minus y, so b is 10. And c is 8 minus z, so c is equal to 8. So we have now completed all the work. So in terms of the marks, so there were 11 marks in total. You will have got 2 marks for the initial table, so putting the results into the initial table. That's using this result that we had right at the very beginning on the last slide. You'll get 1 mark for the pivot column and 1 mark for the correct pivot and showing your ratio test. You'll then get a mark for seeing that the pivot row would remain unchanged, because in this particular case the pivot was 1. You'll then get a mark for attempting to get these other rows, that's row 5, 7 and 8, correct, and showing the calculations, and a method mark for and an accuracy mark for getting the correct table. So 8 marks by this stage. You then got a mark for writing down the value x equals 8, y equals 0 and z equals 0, and a method and an accuracy mark for working out the value of a, b and c. So it's always worth just doing that carefully as well. There were 2 marks. So if we have a quick look then at the last part of that question, it says, if additionally the variables a, b and c are non-negative, what additional constraints are there on the values of x, y and z? So we already know that x, y and z have got to be greater than or equal to 0, but we also know that a is equal to 20 minus x. So if a is non-negative, that means that that has got to be greater than or equal to 0. And that of course means that x has got to be less than 20. So that's an additional constraint, because we already know that x had to be greater than or equal to 0. So now we know between 0 and 20. And we can do a similar thing. B was equal to 10 minus y, and again, if b has got to be non-negative, then that means that y will have to be less than or equal to 10, and c was equal to 8 minus z. And again, if that's non-negative, that means that z will have to be less than or equal to 8. So again, a method and an accuracy mark for that. So I'm going to finish this session here and just remind you, as always, that the best way to revise your maths is through doing lots of examples.